All right, today we'll be talking about winds and how wind can affect aviation operations um, around the world. So we'll talk about global winds on a large scale, and then come down a little bit smaller into uh, local winds, um, and then kind of work it in even further towards a micro scale wind uh, and how even small winds can affect aviation. So first, talk about global winds. In the northern hemisphere, the wind generally flows from west to east, and that's what you'll find in the jet stream, which is a fast-moving area of wind high in the atmosphere. Generally, it's going to start in the United States in the Pacific Northwest and come across the United States from the west to the east, usually dipping down to the south or north, depending on what season it is. A couple of different types of winds that you'll hear about in aviation are a land breeze and a sea breeze. And talking about coastal winds, you have to understand that wind is I guess it's caused by uneven heating of the Earth's surface. So anytime you have a hot area and a cool area, the wind is going to flow from the hot area to the cool area. So it always goes from hot to cold. Keeping that in mind, there are a couple of different types of winds associated with the coast, the land breeze, and the sea breeze. The sea breeze occurs in the daytime when the sun is out and it's heating the land, and the land heats up faster than the water. And so you have a really warm area over the land, and that air rises up and pulls the cool air from the sea in to replace it. So you've got rising air over the land, and then winds coming from the water over land to come in behind it. So that's called a sea breeze. And then conversely, at night, there's a land breeze. The land breeze is just the opposite. The land cools down faster than the water, and the water retains the heat a little bit better. So you've got a little bit of rising air in the water, and then you've got the cool air coming from the land to the water to replace it. Another thing to be aware of as we work westward across the United States is a phenomenon called mountain wave. And mountain waves occur when fast-moving air hits a mountain range like the Rocky Mountains, and it will cause the wind to create a wave over the mountains and then come back down on the other side. And that wave can perpetuate for hundreds of miles depending on how strong the winds are. So if you're flying on the eastern side of a mountain range, you can expect on a windy day, you can expect some turbulence, even hundreds of miles to the east of that range. So that's something to keep in mind in aviation for sure. Also associated with the mountains, there are adiabatic and katabatic winds. Adiabatic winds are what's known as an upslope wind. When the sun heats up the mountain slope quicker than it does the valley, so as the sun rises, it hits the mountains sooner, which causes the mountain slope to warm up, and that air, the warming air, rises and it draws the cool air up from the valley, and you get the upslope wind. Conversely, the katabatic winds occur at night when the mountains cool down quicker and the valley below still holds a little bit of heat, so you've got the air going downslope, and that's called a katabatic wind. And those are more micro scale winds. It can occur with a single mountain or a mountain range. Just something to be aware of if you're flying in mountainous areas. I covered that, and then also wind shear. Wind shear can really occur anywhere at any time, and all wind shear is a change in velocity or direction of the wind. So if the wind stays in a certain direction but changes speed, that's considered wind shear. Or if the speed stays the same and the direction shifts, that's also considered wind shear. Wind shear can be a problem in aviation. Obviously, it can cause turbulence, and if it's strong enough, then it can cause real problems. Wind shear associated with thunderstorms can be sometimes termed as microbursts, and that wind can exceed 6,000 feet per minute, a downdraft, which can really put almost any aircraft into trouble. So something to be aware of. And in aviation, when we talk about winds, we're talking about wind speed in knots, and wind direction is always going to be in the magnetic direction. So so you hear a wind 330 at 10, that's 330 degrees magnetic, so out of the northwest at 10 knots. And it's always expressed in knots rather than miles per hour. So something to keep in mind there. Okay. As far as it applies to aviation, anytime you're taking off and landing, you're going to want to do that if you can into the wind and try and utilize the wind to create lift over your airfoil, whether it's a helicopter or airplane. Taking off and landing into the wind is always going to be your best bet. If you can't do that, you want to do something as close to that as possible, maybe a quartering headwind or a crosswind. Try to avoid tailwinds, primarily because they decrease performance significantly. And then also be aware of any wind shear that might be in the area. Buildings and trees, different structures can create various obstacles for the wind to try and go around, and whenever the wind does go around those obstacles, it's going to at least change the direction of the wind and maybe the speed as well. So down low, you've got wind shear, or possibility of wind shear, anytime you're taking off or landing, and that's something to keep in mind there. Okay, I think that's pretty much covers the subject of wind, and thank you for listening.